welcome back. Sorry, if there's an end quote, there should be a start quote. Hopefully you enjoyed your 3-day weekend. So, who can remind us kind of what we've been talking about and take a guess of what compound events means? So my people who are sketching or behind or looking at a section that isn't your math section, please get with us. Who has a guess of what compound events means? Zach?
So it's a multiple events. So maybe you're playing cards and you get dealt a ace. There's and then the person next gets dealt another ace. So then that's two events, so it's compound.
Now, do the events have to relate? I agree with what you just said, but I'm going to push you even further. Because those two events related. They're both card decks, right? Do the events have to relate to each other? You might not know this. You're taking a risk.
Probably.
They actually do not. So, compound events. You might want to write this down. Compound events means multiple outcomes occurring. They could be related. They don't have to be, though. So on your mini mastery from last week that some of you want more time on, so please, AO or extensions today is the only more. Actually, I'm going to try to carve out a little bit of time in the class today. But if you need a little bit more time on that mini mastery, I did not grade them yet because people asked me, can we have more time on Monday? Compound events is multiple outcomes happening. So we're going to play a game in 79 about that. So keep out your orchid sheet. But right now we're going to look at 76. So we are going to be on graph paper for a moment. So we're not looking at your orchid sheet yet, but keep it out because notice this one says 79. Right, so keep this out. So examples from class. So Nina's buying a new pet fish. At Pet Store, the fish tank has equal numbers of two kinds of fish, tetras and guppies. Real fish. That's why I like sleeping. I used to have tetras. Each kind of fish comes in 4 different colors, yellow, orange, blue, and silver. There are equal numbers of each color in the fish tank. That would be very rare to have equal numbers of fish, but okay, that's what we have. So if Nina scoops out a fish at random, what is the probability she will scoop out a silver tetra? So talk with your partner here. What do you think? If Nina scoops out one fish from the fish tank, there are tetras and guppies, and then each of those fish have 4 colors. Talk with each other. Nikki, what do you think?
I would say that it's 1/8 because I'm kind of making a chart.
Like a table or a tree diagram or what?
Yeah, tree diagram.
Tree diagram?
So for the fish, there are 3 different kinds of fish. You have guppy and tetra. And then those also split into 4 different colors.
So we have guppies and we have tetras. And then each of these you said splits into 4 different colors. So at the bottom we actually have 8 options. Right? You don't even have to fill in the whole thing to think through how do we get to 8 options. Another way we can think about this, because there's only 2 things happening here, probability table. Right? We can use a probability table anytime that there are just 2 things happening. So our 2 things is type of fish, color of fish, right? Those 2 things happen. The other thing we can do, and I heard a couple of you guys talk about this, and I would ask that you write this down if you haven't thought about this before. The probability of the one event times the probability of the other event. Because if we want a silver tetra or a blue guppy, or you have a 1/2 chance at the type of fish and a 1/4 chance at the color you want. 1/4 times 1/2 makes 1/8. questions, kind of bringing that back up in our brain and remembering what we did last week? Thank you very much, Nikki, for bringing up the tree. So we think about testing this out. So Nina decides that thinking about the area will help her find out other probabilities. So she's going to play a game with cubes in a bag, right? When you guys get bored at home, you put cubes in a bag and play a game, right? Totally. No. So we have 2 blue and 1 yellow. So please, on your paper, put a 77 somewhere, like in a box or something. And write 2 blue, 1 yellow. You can just do 2B, 1Y, 3 cubes total, right? You decide how you want to draw this out. You don't have to do this, right? So use some sort of systematic list. Probability tree, probability table. What is she doing? Pulling out 1 cube, putting it back, and drawing another one. She pulls 1, puts it back, draws another. Pulls 1, puts it back, draws another. I'm going to draw a tree first. Oh, our pencil's not moving. Zach, is the second draw independent or dependent?
Independent.
Why?
Because, like, you're putting the block back.
Yeah, we put the block back, right? We reset the situation, which means it's independent. So this, I can still get a blue, or a yellow. From here we could get a blue, or a yellow. You can. I mean, I asked you to do whatever you wanted to do. You could have done a table. I don't care if you do a table. Now, is getting this blue a different outcome than getting this blue? Kind of, right? So it's a different block, but if I just care about what 2 colors did I have at the end, would this look different than that in the result that I tell you I had a blue and a yellow, or a blue and a blue, or like, no, they're both blue, right? So unlike in a deck of cards where every card is unique, those 2 blues are identical. So if we come back up here to this table, aren't these outcomes really the same? And aren't these outcomes really the same? And this is what I told you last week we're going to start doing with these tables. Draw a new table, but we're not even going to draw it exactly like this. Follow with me to draw this table. So draw a square. Okay, and I'm going to use a square to make sure that I stay honest. Draw a square. Now, in your square, try to go 2/3 of the way over and drop a line down. Then go 2/3 of the way down and drop a line over. Or drop a line over, yes. What is the actual probability of getting that blue block? Okay. 2/3. And since we reset the situation, draw 2 is also a 2/3 chance at blue. Which leaves yellow with what chance? 1/3. So then in the table, we can calculate the results of these draws. So my chance of getting a blue and then a blue is what goes here. But last week, all we did was put blue, blue. Now what we want to put is what is that actual probability. Now everybody stop for just a minute. Put your pencils down. Have you ever played darts? Like dartboard? Like you just... Toby didn't even flinch. What if I'd actually throw him at you? So, on a dartboard, what's the hardest thing to get? Bullseye. Why is it hard to get? Who can talk, like, Toby, why is the bullseye hard?
Small in the middle, and you have to have perfect aim to get it.
So we would say the probability of getting a bullseye is very small because the space it takes up is a small amount of space. Guys, this is a dartboard. The probability, if you draw your probability table accurately, and that's why I said don't draw up here, they made this space look the same as this space. Is that true? No! Blue is more likely. So if we're trying to draw an accurate diagram, we want to make things bigger if they're more likely, smaller if they're less likely. So blue and blue is the most likely outcome. What's the least likely outcome? Yeah, yellow and yellow, right? So fill in this table, and if you don't know how, we'll do it together in a second. But what outcome goes in these regions? Yeah, yellow, blue, or blue, yellow, right? So this is going to be yellow, blue. And this is going to be blue, yellow. What is 2/3 times 2/3? 4/9. What is 1/3 times 2/3? 2/9. Careful. What is 2/3 times 1/3? Still 2/9. What is 1/3 times 1/3? Guys, please fill this in your notes. This is the first time we've done this. This is brand new. What's 4 plus 2 plus 2 plus 1? 9. 9/9. Right? The whole table equals 9/9 because it's all possible outcomes. Now, Araya, which is more likely? Ending up with blue-blue or ending up with a mix of blue-yellow?
Well, technically, wait, it's an equivalent amount.
Why?
Because there's two squares that equal 2/9, and we just put them together, so that would be 4/9, so it's just equivalent.
If we don't care about order, right? Because this one is yellow then blue, and this one's blue then yellow. But if we don't care about order, and we say which is more likely, blue-blue or a mix, because they're equal. This one's split up, but if we talk about just what's the probability that your result is mixed, both of these are mixed. So we got to add them. 2/9 plus 2/9, like Araya said, makes 4/9. That's equal to our blue-blue. So even though it's split up, these two spaces would equal this space. This is what we call an area model. So please, off to the side of here, write area model. Because if I ask you, draw an area model for something, this is what we're talking about. You want to size it appropriately. Bigger probability gets bigger space. Lesser probability gets lesser space. Any questions on what we're talking about here? The 2/3 had twice as much space as the 1/3. 4/9 inside gets more space than 2/9. 1/9 is obviously the smallest. Now you can use graph paper to make these really accurate, right? If you made the blue 4 boxes wide, then your yellow should be 2 boxes wide, right? Because 2/3 versus 1/3. Or if you made it 2 boxes wide and 1 box wide, but that would be really small. All right, so try this on your own. The pet store Yes, I spend a lot of money on pet food. On a slow day, 3 people buy cat food, 2 people buy dog food, and 1 person buys food for a pet snake. Hmm? Yeah, like mice or whatever. So on your paper, I'm going to have you do this on your own, but I can tell by the side conversation, pets just get us too excited. 3 cat, 2 dog, 1 snake. Yep, we're going to make an area model. And then the other thing we're talking about is what? How they pay. So food they buy versus how they pay, right? Food they buy versus how they pay. If we're going to make a table. So if we want to try to make our area model nice, we make a square first. I'm going to check, half pay with cash, half pay with credit card. That makes things easier for us. I'm going to go ahead and draw my half because that's going to be easy. Now make sure you include those fractions. Cash is a half, credit's a half. 3 cat. You don't actually write 3 cat. How many total food purchases were there? 6. So for cat, when we write cat, what goes with it? 3/6. Or a half, right? Cat had 3 of the purchases, but out of 6. So how much of this table is it going to get? Half of it. So I come over to the halfway point. My table should be cut in fourths right now. Because cat got half. Right? Then dog is going to get 2 out of the 6. And then snake gets 1 out of the 6. Guys, everybody pause and be honest with me. Right? Do you trust me that I'm here to help you? Okay. Look, I get that you want to be silly, but like the people that might be concerned, like, I don't really want to ask the question. Like, come on, don't be silly right now. If you don't understand why we set this up like we did, please ask me something right now. Cat gets the widest space because it was 3 of the purchases. And if you wanted to on your graph paper, you could make this 6 boxes wide and just go 3 boxes for cat, 2 boxes for dog, and 1 box for snake. It doesn't really matter how tall it is because we have to split it in half. So you could have just gone 2 boxes tall and gone 1 box, 1 box. Now you're going to have a really small table if you do that. But this should be 3 wide, 2 wide, 1 wide. You all good? Yeah, right. Yeah, I mean I had a pet snake for a little while, but when I took it to scout camp and let it go, I didn't think it was happy. So I don't think any animal is probably really happy in captivity. So fill this probability table in with just, I'm not even going to make you write what happened, just the fractions that go there. So this, and I'm going to write it, but you don't have to, this is somebody who bought cat food and paid with cash money. It's 1/2, if we look at the reduced, times 1/2. This should be 1/4. This would be, well, if I reduce this, it's actually 1/3 up here. So 1/3 times 1/2. So this is 1/6 in this space. here is 1/6 times 1/2. 1/12. And what could we say about the bottom? Fill in the bottom. And if your brain's really tuned in, you could figure something out pretty quickly.
Hey, wait a minute.
When this side of your table splits up identically, the top part of the table and the bottom part of the table will be identical. So this would be a 1/4, this would be a 1/6, and this would be a 1/12. Now showing that the whole table equals 1 would be a bit harder here, because we'd have to get to common denominators of 12. Right, so this would be 2/12. This would be 3/12. 3 plus 2 plus 1, 6/12. Plus another 6/12. So if you were asked, try to answer this independently, like don't immediately talk to a neighbor. What was the probability a person bought food for a snake using a credit card? Find that on your table right now. Like right now on your paper circle. What's the probability somebody bought food for a snake using a credit card? Meredith? 1/12, because that is this right here. Food for a snake, buying a credit or using a credit card. Find that intersection on the table. Question. This probably wouldn't happen. Equal cash credit. Most people probably pay with credit cards these days. All right. Mystery spinner time. Y'all ready to compete against me?
No.
No.
It's not rigged.
Your games are always rigged.
You know how to win in advance of us.
He's 39.
What do you mean I know how to win in advance of you?
Because you're the one
Because you're
you're
2
the
steps
teacher.
ahead and not, and we're 2 steps behind.
You know that we know, Hudson.
Yeah.
Multiple.
You're a cheater light.
I'm not a
You are a man of trickery.
You're all hurting my feelings. Quite honestly. Like my heart is already broken and you're breaking it. So
Did you take your
I did. We are going to spin each spinner. We're going to spin each spinner. We're going to add the results. And if the sum is even, one team gets a point. And if the sum is odd, the other team gets a point. You guys have 5 minutes to, as a class, and you probably won't use all this, decide, do you want to gamble on even or odd? Now think about what we have just been doing, and you have the spinner information right here. Spinner A has 2, 3, and 4 on it. Spinner B has 6, 7, and 8 on it. I need you guys to model out what are the possible results here should you bet on even or odd. Talk with each other.
Oh wait, talk to them. Wait, does it matter? Look, everybody.
Yeah.
Okay,
Figure it out as a class.
Two even numbers in spinner A and 2 even numbers in spinner B. So the 1 odd number in spinner A and 1 odd number in spinner B. So then 2 is better than 1 because 2 is a bigger number, and then plus another 2, and then there's only 1 in spinner B.
It's a very convoluted way of explaining it.
Okay. Well, I'll go with even, I guess. Yeah. We're gonna go even. I don't know. Is it really? I don't know if it really matters. I mean, look, because you're even. Because there's 2 here. Okay.
Everybody sketch a table on your paper to look at the results.
Wait, are purple paper?
Either. Graph paper, purple paper. Purple people eater. Yeah, one-eyed, one-horned, flying. So wait, we got 2, 3, 4. from one spinner, 6, 7, 8 from the other spinner. So if we went 2 and 6, is that even or odd? Even, right? We don't even really need to write the result. We went 3 and 6, so fill these in. No, that's odd. Oh, odd. Ooh, odd and odd make even. Oh, you guys probably knew that, though. Right? Like, so Nick was up here saying a lot of words that I think all mean that you guys want to bet on even. Sorry, it's hard to see with the glare. Eric?
Mr. Hudson, I'm putting all my money on odd.
Why?
Because we don't, okay, yeah, sure, if at the first glance, the odds, funny, are in favor of even, but you don't know the sizing of the probabilities
Eric,
because...
you're taking mine.
Yeah, Nick,
I explained this to Eric. Why I think
Well, but now if he understands it, he can explain it to other people, right?
Exactly. Conveying your knowledge.
you're a hacker, man.
Don't be upset that he's sharing something. So hold on, Eric, what were you saying?
So basically, like, if you don't know the size of the portions, like, sure, they're more even numbers, but the evens can be really small, and, like, the odd could just be, like, this giant surpassing thing.
Surpassing. All right, so what can help us figure out if this is, like, a trickery bamboozle sort of situation or, like, an honest type situation? Lydia? Shh. Let's spin sometimes and collect some data. So if we get a 3, so write these down, 3 and 7. So make a little space on your graph paper for spinner 1, spinner 2. We get a 3 and a 7. We got a 3 and a 7. Spinner 1 gave us a 3, spinner 2 gave us. So you should be keeping track of these things. We got to collect a lot of data really quickly. Spin again, we get another 3 and another 7. Spin again, 4 and 7. So we've gotten spinner 1 is 3, 3, 4. Spinner 2 is 7, 7, 7. Another 3 and then a 6. Another 3 and then a 6. Another 3 and an 8. Another 3 and a 7. Another 3 and another 7. Another 3 and an 8. Another 3 and a 6. Another 3 and a 7. Another 3 and a 6. I don't kid. 2! We got a 2! And a 7. Ah, 3, 7. Guys, these are our spinners. Hey, Lydia, you want to tell the class?
it was rich.
Shh, say it louder. It's on your paper.
Oh my god, Hudson.
Lose the turn.
So,
This is absurd.
hold on. Shh. But you haven't made your bet yet, right? I didn't, even though Nick wanted to tell me what to do, I didn't let Nick make the bet. Go redo the table on your graph paper, draw a new table, knowing what the spinners look like. On the graph paper. So spinner 2 is fair, quote unquote, right? Spinner 2 is fair. Spinner 1 is not.
No, I see this pretty fair. I bet I'm not Oh, wait, it was on there. Oh, wait, it was on there.
Okay, we're making this fraction.
Yeah, but you have to indicate what's there.
So that's
So guys, the easy part of our table is 6, 7, 8, right? The 6, 7, 8 for spin 2, that's easy. Third, third, third. The difficult part's the 3, 4, 5. Yeah? Was it 3, 4, 5?
2, 3, 4.
2, 3, 4. Sorry. So if we go in order, our 2 has a probability of what? 1/8. So it gets a real small section. The 3 has a 3/4 probability. Or 6/8. Yeah, if you wanted to talk all in eighths. So if you made your 2 have 1 box wide, then this gets 6 boxes wide, if we're drawing it appropriately sized. And then the 4 is also a probability of 1/8. Yeah, it's an eighth of a circle.
What?
You have it here. Sorry, I guess I could have let you do this down here, but graph paper is easier to work on when you can count the boxes. So there was space here, but the boxes make your life easier. So if you're asked to do an area model, my advice would be graph paper. We are going to pick this up tomorrow, right when we start class, like right here. So for now, if you weren't done with the mini mastery and you wanted more time to work on it, now is that time. If you were done, then you're just working on homework for the next 10 minutes. Okay, so 526 is homework for today and probably tomorrow. If you want your quiz back, come get it. I'm just going to lay them out over here. Toby, Molly, Morgan, Eric, Maeve, Luz, Zach, Araya, Callie, Savannah, Olivia, Nikki, Nick, Bella, Leah, Lily, Sarah.
Not done.
Oh. Gotcha. Did you guys plan that out to say that together? I had the stack of extra quizzes this morning.
Oh no, you lost it.
I do not believe that
Just throw this back into you since I'm done, or do I just leave it there?
Sure, I said if you weren't done. Don't set up your graph like this. That will be a bad idea because you won't have enough space. That. So you guys can actually take these out of class. If you don't, try to get them back to me by the end of the day. Okay? Guys, we're not talking. We're trying to finish these. So we're going to go ahead and say that if you are not done with this and it's time to leave class, finish it for homework. That's higher priority than your 526 homework because that's not due till Friday. But we need to go over this mini mastery tomorrow. Like we have to review it and talk about like what do we have mastered? What do we need to work on still? So if you don't have it done before you walk out of here in like 7 minutes, take it with you, finish it tonight, do not lose it. Okay, we'll go over them together tomorrow. I don't know if this grade will ever go into math, but that doesn't matter, right? You want the feedback. Your parents don't really matter that much. And your learning, guys, your learning, come on, your parents don't really impact your learning all that much anymore. It's up to you. There are 52 cards in the deck, yes. Regular deck, no jokers, no special, 52 cards. Toby, why are you talking?